I'd like to talk about a topic that I find fascinating and one that needs a lot more clarification. We're going to take a look at many different experimental results, and also we're going to tour the universe from its smallest to its largest structures, looking specifically at the way that electromagnetic and plasma phenomena scale. We're going to compare the radial inverse square effects of electromagnetism and gravity, in contrast with the swirling and the twisting E cross B effect that only occurs in electromagnetism. So I hope that these ideas spark interesting and useful connections for you. So let's begin with an observation. I've long been intrigued by the fact that hurricanes and galaxies look alike. Not just similar, but almost identical in structure. This seems to beg an obvious question to me. Why? And they both look like the Nautilus shell. When I was first starting to look into this, I took an image of a Nautilus shell, I duplicated it at 180 degrees to make the double spiral, and I superimposed the galaxy image. We see that the bright star clusters seem to occur in the same places where we find the lines and the nodes on the shell. And we see the same with hurricanes and those vortical hot towers, those more intense turbulent regions within the rain bands. And if those are merely regions of turbulence, what could cause this kind of turbulence across galactic space? And is there a reason that even the textures look so similar? Why should the striations that show up in the texture of a shell also manifest so similarly in the cloud formations of a hurricane? Is there more going on here than at first glance? We know that nature doesn't work by coincidence. It works by simple rules and predictable forces that interact to generate the complex reality that we see. So if things have the same shape, it seems reasonable to investigate whether there are common forces at work. So we have a question. What forces might hurricane formation and galaxy formation have in common? And why do we see these helical rotations and fractal spirals showing up in structures throughout nature and across so many different scale factors? We see them in shells, cabbage, animal horns, DNA, the cochlea of the ear, the arrangement of seeds or petals on the face of a flower, a seahorse tail, the aurora. Even the solar system has helical structure as it spirals its way through the galaxy at about 70,000 kilometers every second. So how can hurricanes and galaxies form such similar structures, when one occurs in tropical storm conditions and the other one happens across vast reaches of interstellar space? Those who believe galaxy formation is caused by gravity alone don't believe that hurricanes are formed by gravity, and those who believe that hurricane formation is caused by the convection forces and the Coriolis effect don't believe that galaxies are formed by convection or Coriolis. So is it possible that in both systems even stronger forces are at play? So we'll get back to the Coriolis effect a little bit later on. First, let's examine this geometry a little further. The golden spiral is a fractal shape, and we see many other fractal shapes, self-similar shapes throughout nature: coastlines, trees, lightning, cloud formations, many more. So let's begin by looking into this fractal geometry. We describe the golden spiral numerically using the Fibonacci sequence, the ratio 1.618, but this only describes the fractal shape. It doesn't explain the cause. So fractals occur when a simple rule or an equation is iterated back onto itself many times in a recursive fashion. In this way, a simple rule can manifest as a system of great complexity. Many fractals are so mathematically complex that we needed very fast computers before we could model their fine detail properly. Here is a computer-generated fractal image, and here is a photo that my mom took in the grocery store for me because she knows how I feel about this subject. That's just broccoli. No digital effects are applied. It's an incredible example of natural self-similarity. The most famous fractal is probably the Mandelbrot set, which is based on this quadratic function. And we know how often the quadratic relationship shows up in physics and nature. Anything parabolic, all of the inverse square relationships like gravity and electromagnetism. So let's watch now for a moment as we zoom into the infinite detail and complexity that's generated by a simple quadratic rule iterating onto itself millions of times across many different scale factors. As an aside, by the way, this Mandelbrot equation does use real and imaginary or complex numbers. The complex numbers on the y-axis and the real numbers are on the x-axis. Now, some people might think that this means that the shapes that we get out of this kind of math should also be imaginary and shouldn't resemble actual structures in the real world, but this is not the case. Complex numbers are just a mathematical tool that allows us to work more conveniently with rotational motion. It does this because it introduces a recursive oscillating element, because I flips between positive and negative numbers when you rotate its value around the unit circle, like when you use e to the I theta, for example. So I simply transforms an exponential function into an oscillatory function. Now, we could achieve the same effect using even more complex numbers, but ones that are more realistic algebras, like the quaternion algebra, for example. The point is that complex numbers introduce an essential feature of the underlying nature of the reality, that many systems in nature come back and return on themselves. So to illustrate how powerful this kind of abstraction can actually be, Lou Kaufman derives a good part of the mathematical structure of physics from an even simpler abstraction in his presentation on non-commutative worlds. Anyway, back to the Mandelbrot set. Notice as we are scaling how many of these fractal structures look natural, cellular, vortex-like because of this quadratic relationship. Now, the main macroscopic features of the Mandelbrot set are a cardioid and a circle. A cardioid is generated when a circle rotates around another circle. So we might expect these shapes to be associated with rotations or with rotational resonances. A cardioid is also the inverse of a parabola across the unit circle. And we will return to this inverse relationship later and what it suggests about the relationship between the real world and the maths. For now, though, let's just mention that the cardioid is also the shape that's traced by the E and the B fields in a circularly polarized photon when it's coming right at you, that is. So, where might we look for an answer to our question? We need to find a simple set of laws that operates at all scale factors of nature and that behaves in a fractal way, and that could account for these spiral or these helical rotational formations. So, could electromagnetism be our prime contender? As far as we can tell, everything in the universe is made up of energy density. Everything that we are familiar with is made up of particles, either in the form of radiation or rest massive particles. Now, the nature of these particles is itself partly electromagnetic, as John Williamson, Martin van der Mark, and Vivian Robinson's work is actually illuminating. So these things exist everywhere that we know of, and they can transform into each other. Is it possible then that electromagnetism can influence structural formations in length scales from the galactic to hurricanes to living things and even down to elementary particles? Let's think about this. Electromagnetism has basic laws that we understand pretty well, but can they yield fractal, spiral, or helical structures that we see in nature? So let's investigate this from first principles. We know that opposite charges attract and like charges repel. With electric current, though, it's the opposite. Currents flowing in the same direction attract each other, and currents flowing in opposite directions repel each other. And what happens when they meet? If the currents are confined in solid-state wires, they'll just approach each other and then remain beside each other because the metal atoms are actually fixed in place. But in plasmas, both the ions and the electrons are free to move, and they do. So, plasma currents will approach each other and then they'll begin to twist around each other. The interference from the magnetic fields serves to stabilize and constrain that central current channel. This is called a Birkeland current filament in honor of Christian Birkeland, the Norwegian plasma physicist who explained the aurora borealis phenomenon. So if we use a simple vector to represent the magnetic field of a right-hand rule current strand, and then we add a second current strand separated by, say, a unit radius, we can get an intuitive sense of the shape that such a rotating system of fields might generate. And if we combine the vectors for the two adjacent strands into one, we get a spiral vector field. Does this imply that parallel electric current flow through any partially ionized fluid medium can result in a spiral or a helix? Now, the Z term in the simulation here on the right is chosen just to model the aspect of a flux rope, where the current helix is increasingly vertical the closer you get to the center of the channel, which represents the strongest current flow. This also illustrates, by the way, how the same field can be operating both in the axial and the equatorial directions of the same system, depending on how far they are from the axis. Now, since particles have spin, they also have angular momentum. And by the way, notice how all of those equations are quadratic. Photons also have angular momentum. And as charges flow in a plasma current, they're going to flow in a helical path, which means plasma currents will also have angular momentum as they flow. So if we couple two of these currents with angular momentum that are going in the same direction, the collective effect must yield a rotating system for angular momentum to be conserved. And if you consider how many charged particle trajectories that there are in that current system, we should probably expect to see a fractal rotating system within rotating systems. The Nobel Prize winner Hannes Alfvén, who was a student of Christian Birkeland, clarified from Maxwell's equations that plasma phenomena scale. They increase, for example, in length in proportion to their increase in duration. So if you scale down a 50 millisecond, 1 kilometer long lightning discharge by a factor of about 50,000 to the size of a 2 centimeter spark discharge in the lab, it will also have a duration about 50,000 times shorter, of about a microsecond. But otherwise, they are structurally very similar. So if we look across all scale factors of the universe, scaling in time and physical dimension, we should expect to see electromagnetic plasma structures. So before we look at research that might serve as evidence of this electromagnetic influence, let's consider what shapes we would expect to see in nature if electromagnetic scalable plasma phenomena were at work. So spark discharges like lightning occur in filaments. Atoms, s orbitals, and charge fields are spherical. Magnetic fields form concentric tori around the equator of a magnetic system. Subatomic orbitals have lobes and sometimes also a torus around their waist. So if there are inverse square parabolic forces or rotational resonances at work, we should expect to see shapes also related to cardioids, since they are the spacetime inverse of parabolic motion, as well as shapes related to spirals and helices. Solar flares show helical structure, as do laser optical vortices or a circularly polarized photon. And as we mentioned before, when you look at the photons E and B fields end on, they each trace a cardioid shape. Relativistically though, from the photon's point of view, they actually trace a two-dimensional cardioid because according to relativity, the photon experiences its emission and absorption events simultaneously. Now, in terms of filamentary structure, we do see Birkeland currents in space plasmas. We see them in solar coronal emissions and in the magnetosphere of Earth and the other planets. Birkeland currents may also be able to explain an interesting phenomenon that we see on Saturn. NASA's Cassini mission garnered some incredible data and footage of Saturn. Here we see an infrared image taken from above the North Pole, which shows concentric axial topography, which is interesting. And above it, we see an image captured by cosmologist Anthony Peratt, who was a student of Alfvén, which shows the cross-section of a Birkeland current in a laboratory-dense plasma focus device. And this remarkable time-lapse footage that NASA and the JPL put together from the Cassini mission shows distinct counter-rotation around Saturn's North Pole, which is something the standard model has great difficulty explaining. Furthermore, counter-rotation has also been observed at the galactic level, for example Messier 77, as this image from the ALMA array shows. The blue regions show that material is moving towards us and the red regions moving away from us. Now, in his 2015 paper on Birkeland currents, Donald Scott described the mathematics of this force-free field-aligned current system, which he believes provides a mechanism for counter-rotation. We see that in a Birkeland current, concentric cylindrical regions counter-rotate because the magnetic field changes direction as a function of radial distance from the axis. According to the electric universe folks, this explains Saturn's anomalous counter-rotation and may even also account for galactic counter-rotation. So Anthony Peratt also performed a simulation of parallel laboratory plasma currents, and his results bear a striking similarity to galaxy structure. Now here are a few examples of how subatomic and galactic phenomena exhibit remarkable structural similarity. Now, do galaxies and quantum electron orbitals have the same shape because they are somehow related through similar fractal or resonant plasma scaling? We know that plasma effects do maintain their shape at any scale, so that does make them a good candidate for this. On the right, we see the similarity of the classic sphere in a torus shape of the galaxy called Hoag's object, and also the fine ring nebula just underneath it, compared with some of the latest research into the substructure of the electron. This is work by Dr. John G. Williamson, formerly of CERN and the University of Glasgow, and the late Dr. Martin van der Mark of Philips in the Netherlands, which investigates the way in which energy and matter interconvert. So we'll talk more about this in a moment. Now, in the electric model of the universe, Star formation may be also related to a plasma Z-pinch or a Bennett pinch effect, which is named after the American plasma physicist Willard Harrison Bennett, since current tends to focus plasma into filaments, concentrating matter as we described above. Now, Bennett hypothesized this effect because the solar wind is not a uniform emission, but it's filamentary in nature. We are most familiar with this Bennett pinch effect in lightning, which is both a plasma pinching effect as well as fractal structure in the breakdown potentials of the leader streams. If the plasma or the current density were to increase, then the pinching effect of the current that's passing through it should also be increased. Now, some in the electric universe camp believe that this dense plasma focus is the cause of stellar fusion. In addition, Birkeland currents tend to organize elements according to their ionization potential. This is called Markland convection. Hannes Alphen described the process saying, elements with the lowest ionization potential are brought closest to the axis and form concentric hollow cylinders whose radii increase with ionization potential. The drift of ionized matter from the surroundings into the rope means that the rope acts as an ion pump, which evacuates the surroundings. Regions with extremely low densities can be produced in this way. As we saw before in the flux rope, the strongest current flow will always be along the central axial core. This flow would be most effectively supported by a conductor with the most available electrons for current transmission. These are the low ionization energy metals like iron and nickel, for example. According to the electric universe folks, this might also account for the Earth's core consisting of mostly iron and nickel. Now let's dive deeper. Why does it make sense for matter and energy to exhibit such electromagnetic properties, if that is in fact what these are? The answer may lie in a remarkable new theory put forward by Dr. John G. Williamson and Dr. Martin van der Mark. The Williamson-van der Mark model we mentioned above describes how photons and electrons can morph into one another when radiation becomes confined into or becomes unconfined out of a self-sustaining double-loop rotation. This is where a photon makes two rotations for every one wavelength, tracing a toroidal path in momentum space. Now, the fins on that twisting spiral in the diagram represent the field lines, and they form a dipole magnetic and a monopole electric distribution for this electron snapshot. The model also gives rise to a charge of the order of 10 to the negative 19 coulombs and a half integral spin, which are both consistent with observation and experiment. Incidentally, according to Dr. Williamson, the fact that the magnetic force is stronger than the electric force also explains why we can have an electric monopole, a charge, but not a magnetic monopole. A magnetic monopole would have a far higher mass, which would be unstable, and it would rapidly decay back into an electric monopole. Now, we should also clarify here that torus is a shape that is in momentum space. When this shape is projected into three-dimensional space, we get the shape in the center, which is a spherical manifestation of the energy density. Now, Williamson and van der Mark have developed a new quantum mechanics, a remarkable 4D algebra involving multiple coupled differential equations that govern the current, fields, angular momentum, and mass of all particles. It's a Clifford-Dirac algebra encapsulated in this equation d mu psi g equals 0. This equation is an extension of Maxwell's equations. It's an extension of relativistic quantum mechanics that penetrates into the substructure of particles. We might call it the mathematics of absolute relativity. Now, the important point here is that particles are not axiomatic points. Their properties emerge as a consequence of their substructure. If we take them as axiomatic, we constrain our ability to see to the next level. This is no longer necessary thanks to the work of Williamson and van der Mark. Dr. Williamson points out that geometrically, a circle and a bicircle are conformal inverses of each other. This means that if a wave equation works in one, it will also work in the other. In space-time, the corresponding hypervolumes of the circle and the bicircle, the sphere and the torus, are also inverses of each other. What appears as a torus in momentum space can therefore manifest as a sphere when projected into three dimensions, as we saw above with the structure of the Williamson-van der Mark electron. Now, this inverse relationship in the mathematics also reflects the reality of a photon's emission versus its absorption events, which are space-time mirror images or inverses of one another. Williamson and van der Mark actually calculated the general inverse for every multivector in the Dirac algebra. And it looks like this, for those who are interested. Now, this is very intriguing stuff, because if they are correct, they've also solved a major problem in quantum mechanics, the issue of quantum collapse, the problem that you cannot measure a quantum event without collapsing the very wave function that you're trying to measure. Williamson and van der Mark are showing that the waveform collapses because it's undergoing the collapse necessarily associated with inversion, with going from an emitted thing to an absorbed thing, or vice versa. Now, while the sphere and the torus represent inverses in 3- and 4-dimensional space-time, a 2-dimensional analogy of this effect can be thought of as what happens when a wave in an attached rope becomes inverted when it reflects off of a wall. So this general Williamson-van der Mark inverse is groundbreaking and noteworthy work. Dr. Williamson extends the electron model to describe the proton also as a continuous electromagnetic flow, like the confined photon of the electron, though forming a trefoil not in its momentum space rather than a simple double loop. Dr. Vivian Robinson also believes that all stable particles, protons, neutrons, electrons, and neutrinos, are in fact comprised of photons of the appropriate energy making 2 revolutions per wavelength, though it takes a slightly different path. He explains how these higher energy photon rotations generate powerful energy resonances that give rise to the energy densities that make up these particles. In these diagrams on the right, you will see some very interesting things. First, in the Robinson particle model, charge extends out in the equatorial plane of the particle, while the magnetic fields extend in the axial direction. This gives an overall spherical profile to the energy density of the particle. Pink represents positive charge density in the diagram, and blue represents negative charge density. Second, we see that a neutron is neutral because it contains positive and negative resonances in balance, and not because it contains an actual proton and an electron. However, since the edge of the neutron contains negative electric field, it can bond to a proton's positive electric field when they approach each other edge-on in an equatorial direction. Nucleons thus bind to one another side to side to form nucleon layers in an equatorial distribution, as we see in this image of a helium nucleus or an alpha particle. This also explains the stability of the alpha particle as a unit, as a building block of larger nuclei. Third, these equatorial nucleon layers can then bind to each other magnetically in the axial direction as the layers stack on top of one another, since in that configuration their north and south poles can be aligned and will actually attract each other. This is how a nucleus is built in 3 dimensions, as we see from this exploded view of the nucleon layers that make up the highly symmetrical and stable lead-208 nucleus. Dr. Robinson's model does in fact yield the properties and bond energies observed in these particles. It also explains how and why nuclei bond and decay the way that they do, as well as why certain configurations will form stable nuclei and others will form radioactive nuclei. This is exciting, intuitive, and potentially groundbreaking work that accords with both observation and experiment. The shapes of electron orbitals around atomic nuclei are 3D quantum waves, or spherical harmonic resonance structures. Electromagnetism allows these sorts of solutions, as does gravitation, though gravity waves would be much weaker. And notice how the sphere and the torus are the bookends of 2 of the first resonance structures that we see, giving a nice visual reference for the inverse relationship we were just describing. Harmonic resonances occur naturally between repeating numerical processes, as well as between repeating forces or actions, as we see throughout mathematics and physics. Harmonic simply means that they satisfy the double differential of themselves, that the 3D operator del squared is equal to 0. Now this animation shows beautifully how all of the orbital shapes show up in the spherical harmonic resonance series. This cool resonance by mathologer Burkhard Polster is based on dividing a circle up according to the multiplication tables. As we cycle through them, from a circle it generates a spiral and then a cardioid. Then, as the animation quickly increases the factor of the times tables, it gives us, in a sense, a time-lapse scan through resonance structures, which is fascinating. What's also very interesting is that as it proceeds to higher resonances, it starts to cycle between concentric circles, spirals, cardioids, and what looks like the petals of a flower, 2, 3, 4, 5 petaled and up. So could the galactic shapes also be resonant harmonic coherent 3D oscillations carried through harmonic equations? And if galactic and floral structures are all resonances, which forces are they resonating? Will equations with similar forms resonate in similar ways? Or do similar resonance structures indicate that there's a common causative force at work? An interesting line of inquiry. The discovery of Fermi bubbles, lobes of X-ray and gamma radiation that exist above and below the galactic center, also bear a striking similarity to the spherical harmonic resonance shapes we see in atomic orbitals. And the filamentary nature of the large structures in the cosmos hints more strongly at electromagnetic forces than at gravitational forces, in my opinion. However, Dr. Cantalupo, the researcher who presented this paper, doesn't agree with this assessment. He feels that these structures are nonetheless gravitational. But since both gravity and electromagnetism act radially as inverse squares, though, there are areas where either could describe the effects that we observe. There's also no reason why both shouldn't play a role, and if they did, they would add seamlessly. Now, since we are trying to understand the structure of galaxies, let's delve into how electromagnetism might contribute to this conversation. Cosmologists have long known that stars orbit the galaxy faster than they should if only gravity were at work. If rotation occurred as a result of the force of gravity alone, stars that are closer to the center should orbit faster than stars further from the center, but we do not see this for all the stars. This diagram shows that stars in the outer galactic regions tend to rotate at an almost constant linear speed. What's more, the outer stars should also be orbiting slower than they actually are. The diagram shows us that those outer velocities from about 5 kiloparsecs on are faster than they should be under purely gravitational attraction, and even up to about 4 times faster out beyond the 25 kiloparsec zone. Something is causing them to orbit faster than expected, which poses a problem for the physics of rotation from a purely gravitational point of view. There needs to be more mass present to explain this rotation. The concept of dark matter is employed here in order to compensate for the so-called missing mass. There's a fascinating alternative explanation by Dr. Vivian Robinson as to how electromagnetic forces can come into play at the galactic scale. And while the details of his theory are beyond the scope of this talk, he points out that electromagnetism is about 36 orders of magnitude stronger than gravity. And since they are both inverse square relationships, they weaken equally with distance. His calculations show that if a charge imbalance of a mere one charged particle in 10 to the 18 particles of matter were to develop between the galactic center and its outer regions, it would be enough to account for electromagnetic forces overpowering gravitational forces at these very large galactic scales. Now, cosmic rays can achieve this kind of imbalance because ions, which are more massive, have sufficient momentum to easily penetrate the galactic magnetic fields, causing a positive charge to accumulate at the galactic core. Since electrons are much less massive, they will be more easily deflected by galactic fields, and they will therefore accumulate in the outer stellar regions. According to Dr. Robinson, the existence of a central galactic bulge might provide support for this concept, since, as he puts it, no amount of missing mass could cause the bulge because it requires a repulsive force to push the stars out like that, the kind that might result from an accumulation of positive charge. He's performed calculations and found that the strength of the effect matches the observation, and since the positive field pervades the whole galactic central core, there's no field differential strong enough to rip the stars apart. So now, even if the electromagnetic forces are not running the show on the galactic level, the extra inverse square attraction from such a charge imbalance might be able to account for the faster than expected stellar orbits. The rotational velocity profile of stars within a galaxy is also very similar to the golden mean. And while the rotational wind velocities within a hurricane can also be similar, as in the case of Hurricane Katrina, they often drop off more rapidly, perhaps because of atmospheric drag. So if we compare our intuitive representation from earlier of the magnetic fields around the eye of electromagnetic vortex, it bears a striking similarity to the cloud formations seen around the eye of a hurricane. And while the dusty and bright galactic centers do tend to obscure the detail somewhat, one does have the impression that the same geometry surrounds the galactic center. In terms of the mechanism of hurricane formation, there's no consensus in the literature regarding the mechanism. And in addition, there are certain predictions that have been made by the atmospheric models that haven't stood up over time. There's also a growing body of research from different disciplines that may lend weight to an electromagnetic component in hurricane formation. The Earth is in an intensely electromagnetic region of space, thanks to the sun's intense and constant solar emissions. Christian Birkeland used this understanding to explain the aurora borealis phenomena. His famous experiment using a magnetized sphere called a terrella helped him verify that the aurora happens when a surge of electromagnetic energy overwhelms Earth's magnetic field defense, causing magnetic reconnection to occur between the field lines. This sends a powerful surge of electrical charge spiraling down the vertical magnetic field lines above the poles, and when these charges strike the atoms in the atmosphere, they cause them to glow, just like a glow discharge tube. And the aurora also occur on the other planets too, and for the same reason. But notice that as current flows through Birkeland's magnetized sphere, it jumps across the equator from the south to the north hemisphere. Earth's field lines do the same thing. This phenomena has actually been detected up in our atmosphere too, in the ionosphere, and they're called TFACs, trans-equatorial field-aligned currents. And these make sense because field lines channel force-free paths for current. Charges spiral within these fields in free force, so to speak, because E and M forces are orthogonal to each other. So, if an electric charge is surging along these trans-equatorial field lines, all that is required to connect these electrical surges to hurricane formation near the surface is if current is able to leak down through the atmosphere vertically all the way down to the ground. And we know that this occurs. Electrical discharges traverse the entire depth of our atmosphere. When a lightning bolt finds its way to the ground and establishes its channel, there's a powerful return stroke as the discharge runs both up and down the channel. The lightning's return stroke doesn't stop at the clouds though, it can go all the way up to the ionosphere, and when it does, it often results in these actual glow discharge effects along the way through the entire depth of the atmosphere above the lightning strike. These transitory luminous events are known as sprites, elves, and blue jets. The upper layers of our atmosphere are electrically conductive because they are low-density gases. Now this is high-speed camera footage of a sprite discharge up in the mesosphere. Notice that its frequency profile is virtually identical to that of a regular glow discharge. And in addition to visible discharges, there is in fact also a fair weather electric current that moves charges vertically through the atmosphere by way of ionized aerosol particles. So, if we then add an ion-rich, low-pressure storm environment over warm ocean water into the mix right at the base of these trans-equatorial field lines, electrical activity may well support or even promote cyclogenesis, hurricane formation. As we see, hurricanes do form near the equator in the region where these field lines hit the planet. Now, while they can then move away from the equator, as the paths in this diagram show, they almost always form in this band on either side of the equator. There's research that shows that there's a correlation between various indicators of solar activity and hurricane formation. For example, Atlantic and Pacific hurricanes show a correlation with sunspot cycles, as well as with the 22-year solar cycle. Research also suggests that there's a significant positive correlation between average global geomagnetic activity and hurricane intensity, as well as a characteristic peak in cosmic ray intensity that occurs just before the start of a hurricane. What is interesting is that hurricane season peaks at the equinox, which is when the sun's and the Earth's magnetic fields are the most aligned, and where magnetic reconnection can occur most readily out in the magnetosphere, which is what leads to those surges of electricity through the atmosphere. Now let's return to the Coriolis effect. In the hierarchy of forces, the strongest force is always going to satisfy itself first, usually with a spherical symmetry, and then after that the weaker forces are left to fight it out outside of that region. The Coriolis effect is recognized to be a weak pseudo-force. It can affect large global current and convection cells, but it's too weak to actually affect tornado formation or even the direction that water vortically exits out of your toilet. So the Coriolis effect explains the chirality of hurricanes very nicely, that they are counterclockwise in the northern hemisphere and clockwise in the south. But the question is whether or not electromagnetic forces might also play a role. Consider that if there's a charged particle in Earth's atmosphere, it will certainly be buffeted about by convection forces, but it will almost certainly be far more responsive to Earth's magnetic field than it is to gravity. Electromagnetism is much stronger than gravity, as we said, and so it's certainly also much stronger than the Coriolis effect. So If there are electromagnetic forces present within a hurricane system, which we know there are because of the electric storms, or if these forces are resonating through the storm system, they should certainly be meaningful enough to play some role, even if they are not the architect of the whole system. And consider also that charges that are moving in that way might also do their fair share of shepherding of neutral particles as they go. So it might be short-sighted to rule electromagnetic effects out. And let's once again point out also that if this double golden spiral shape is the result of the Coriolis effect and convective turbulence, galaxies are believed to have neither convective nor Coriolis forces. So it would still not explain their similarity. Now, if we broaden our view somewhat, we see fractal similarities throughout nature. Trees and lightning both exhibit similar branching of their channels. Interestingly, electrode dendrites also form tree-like structures. When charges are trying to bridge the electrode gap to build a bridge across the dielectric between two electrodes, they will actually take particles from the electrode and try and build a bridge across the gap. So this begs the question that if the Earth-Sun relationship is as electric as the research suggests, should we expect to see that the surface of the Earth should also behave as an electrode? And might such an impetus play a role in plant or tree growth on the surface? In the electric universe model, the Sun is believed to behave as a positive anode, and the Earth and the planets will therefore behave as negative cathodes in response. Experiments suggest that beans grow faster when a vertical DC electric field is applied. Leaves are also literally nature's solar cells. Plants need electromagnetic energy to grow, and they grow towards their electromagnetic energy source. And like a p-n junction diode in a solar cell, the electron transport chain in photosynthesis literally converts solar radiation into a flow of electrons. It doesn't seem unreasonable then to wonder at the extent to which electric forces might contribute to plant growth. After all, there is research to suggest that flowers have electric fields and that bees use these fields to navigate to flower heads. As we see from this diagram, different types of flowers have different voltage signatures, and this would allow insects to recognize them and to be selective. Bees can also be disoriented by a strong magnet, which means that they do use magnetism as a sense. And those rotational resonances that we saw earlier from Burkhard Polster also showed us shapes that look just like these flower shapes. Living organisms possess electric fields because of muscle contractions, constant neural and nerve activity, and membrane potentials. Our nerves are literally electric currents because ions are flowing through electrolyte channels called axons, and these generate electric fields as they go. And sharks can detect these fields in the water. They can actually detect them so sensitively that they can pick up charge differences of 5 nanovolts from several feet away, and this enables them to hunt in very low visibility. And they can also use Earth's magnetic fields to navigate. Birds and even some bacteria also have ferromagnetic receptors for use in navigation. And electric eels can generate electric currents so strong they can actually shock a horse into paralysis, about 1 amp at about 600 volts. So electromagnetism is obviously a factor in the lives of many different species. So could these forces then also be instrumental in the formation of living structures? And what type of experiments might be able to test for this? Food for thought. Now, what predictions might emerge from this electromagnetic view of nature? To suggest only two, because Earth withstands this constant electric barrage of the solar wind, Earth's atmosphere should behave as a capacitive buffering system. Charges that leak towards the surface of the Earth are going to face increasingly dense atmospheric layers which will impede their progress. So we should therefore expect to see Langmuir electric double layers at the boundaries between the atmospheric layers, because the interface layer between regions of differing plasma properties will always develop a charge differential. This happens because electrons are lighter than ions, and they therefore have a larger share of the average speeds at any temperature. So this is going to cause a hot plasma region to lose its electrons quicker than it's losing its ions, so it'll build up a positive charge. The cooler region will therefore build up a negative charge because it's receiving electrons faster than ions. So this charge separation should be most measurable at the tropopause, which is the lowest boundary layer, because that's where the gas density transition is the greatest. The upper atmospheric boundaries are more permissive to charge, so a double layer there would be more difficult to detect. This concept also implies that thunderstorms should be the effect, not the cause of the global electrical circuit. Lightning arc discharges are the lowest and the most energetic tier of the global capacitive buffering system because they happen through the densest, least conductive layer of the atmosphere. So charge has to build up very high before it can breach the gap. But we see glow discharge effects happening throughout the entire depth of the atmosphere. And a fair weather current in the 2 picoamp range also falls neatly into the dark current range of the glow discharge spectrum. Now, this is not to say that lightning is only caused by solar activity, because the Earth is obviously a very dynamical electrical system, so turbulence will certainly build up static charge. But it seems unreasonable to presume that the planet's electrical characteristics are generated entirely by weather in the troposphere. It's far more reasonable to me that the terrestrial electromagnetic situation is a consequence of Earth living in the path of the Sun's very powerful plasma current carried by the solar wind. And luckily we have a capacitive electromagnetic buffering system to protect us. Interestingly, predictions that were made by the electric sun model have led a group at the Sapphire project to build and develop a controllable, usable nuclear plasma reactor by modeling in the lab the processes that they believe are taking place on the surface of the sun. Now, their results include the following. They can maintain and repeat multiple different stable, self-organizing plasmas that create their own electromagnetic containment fields. They have stable double-layer shells, plasma tufts similar to those that we see on the sun's photosphere, energy densities that are analogous to that on the sun, and the sequestering of heavy elements to the core, which is reminiscent of the Markland convection that we mentioned above. The Sapphire reactor appears to bear out many of the elements of the electric sun model, including the transmutation of elements, electrode tufting, and the formation of self-confining plasmas. Now, the fact that this model has led to a working plasma reactor is intriguing indeed, and certainly cannot be insignificant. As we mentioned above, in the electric universe model, the sun behaves as a positive anode. So to conclude, is it possible that scalable resonant electromagnetic plasma phenomena may exert a meaningful influence over structural formations throughout nature and across many different scale factors? If so, might it imply that anywhere in nature where we see the golden spiral, that there may be electromagnetic influence at work to some extent, or maybe even electric current flow? Or will equations with similar forms resonate in similar structures? The equations for electromagnetism and gravity do have analogous forms. Both of them are products of either the masses or charges. Both are inverse squares with distance. Both support wave solutions and might therefore yield similar resonance structures. And electromagnetism is stronger by about 36 orders of magnitude. Now, while we cannot conclude from inverse square alone that these phenomena have the same cause, the explanation of their similar shapes is not forthcoming from gravity alone. So we are left to wonder which inverse square law is at work in hurricanes, which in galaxies, and which in the shells of snails and marine mollusks, and by means of what mechanism? Or is it both gravity and electromagnetism acting in concert? Or do similar resonance structures indicate that it is in fact the same force exerting the influence? And if so, which force is it? Is it electromagnetism indeed? So perhaps there is more to this story than meets the eye. The answers certainly remain to be determined, and although some of these ideas may obviously not yet be mainstream, hopefully at the very least we've cleared the way for speculation into some of these fascinating geometries of our universe, and I hope that this inspires interesting thoughts and connections that prove to be useful for you. I would also like to give a special thank you to Dr. John Williamson, Dr. Martin van der Mark, Dr. Vivian Robinson, not only for permission to share some of their work, but also for their invaluable contributions to this presentation. And thank you for your attention, and check out Quicycle.com for a lot more very cool science videos, including presentations by Dr. Williamson and Dr. Robinson on their respective models.